Welcome back to the Advanced Microcontroller series. In this session, we are learning about microcontroller interfaces with clock input-output. And here is the agenda: Introduction and PWM. Most peripheral devices depends on clocking. Controllers have to generate clock to communicate with the peripherals. Some of the controllers internal peripherals work on external clocking provided at its pins. The activity on the devices could be on edges or levels. So here you can see the triggering happens at edges and here also edges. But in this case that activity triggers on levels, not edges. The signal flows from high to low. So this type of triggering is called falling edge triggering. And here signal flows from low to high, and this type of triggering is nothing but rising edge triggering. But in this case triggering happens at the levels. So this is low level and this is the high level. So in case of edge detection, that can either active low or active high, and level detection either low level or high level. There is synchronous data transmission happens with respect to clock pulse, and that can with respect to edge of the clock or level of the clock. In today's session, we are going to discuss about the PWM. So PWM is nothing but pulse width modulation. So in the embedded system, if you want to generate analog output with using digital source, then the PWM is most preferred solution. To understand PWM, we have to know what is pulse. So pulse is nothing but square wave which having two level, low level and high level. So that is also considered. As period. So here you can see this is what repetitive waveform, isn't it? Here you can see the repetitive waveform. So this repetitive waveform is nothing but cycle. The rate of this cycle which appear given amount of time is called frequency. In the PWM, we are going to generate pulse, but we are going to change width of the pulse on the other need. Hence the name is PWM, pulse width modulation. Sometimes it's also called as PDM, means pulse duration modulation. So a technique used to vary the active time versus inactive time in a fixed period. Mostly used to control the average voltage of the load connected. Used in wide applications like motor controls, lamp dimmers, audio, power controls and many more. So now we got idea, right? PWM is nothing but changing the width of the pulse. So here you can see three waveform is there. In all diagram, see period is constant and width is varied. So what is the need? By varying the width of the pulse, we can control the average power which is getting delivered to a electrical load. So PWM, we usually vary the duty cycle of the pulse. So do you know what is duty cycle? So we can say that it is the ratio of pulse width to the pulse period. So what is duty cycle? It is nothing but a measure of time maintained high in a modulated pulse, or ratio of pulse width to the pulse period. To get percentage, just multiply by 100. So pulse period we know, right? Both high and low level, low is nothing but period, right? So that is what pulse having period, right? So that is called pulse period. So another formula for duty cycle is T on divided by T on plus T off. To get percentage save, you need to multiply by percentage. So in the duty cycle we having so many, like 0% duty cycle, 25% duty cycle. Here what is the thing means 25% on period and 75% off period. Here 50% on period, 50% off period. Similarly here 75% on period and 25% off period, and this is the 100% duty cycle. Now let's calculate or find the value of output voltage. So how to find the value of output voltage? So we having formula for output voltage. So here I am going to write the formula for output voltage. So that is V out is equals to V max into duty cycle. So this is the formula to find the value of output voltage. V out means what? Output voltage. V max means what? It is nothing but the system voltage. So assume it is 5 volt. Next, duty cycle. So here we using 75% duty cycle. So we having formula, right, for duty cycle. Let's find duty cycle. So here I am using shortcut DC. 75% means 0.75 is the on period and sum of on period and off period. So that is nothing but 0.75 divided plus 0.75 T on plus T off is nothing but what? 0.25. 0.75 plus 0.25 is nothing but 1. Anything divided by 1 is nothing but how much? That value, isn't it? Here 0.75 divided by 1 is nothing but 0.75. Now we got the answer or value of the duty cycle, that is 0.75. Let's substitute the value and multiply. So 5 into 0.75 is how much? 3.75. That is the answer. Now we got the value of output voltage. So what will happen when you increase the duty cycle? So if I am going to increase this to 1, then 5 ones are 1. This output voltage also increase. So if I am going to decrease the value of duty cycle, instead of writing 0.75, so I am writing 5 into 0.25. So when I decrease the value of duty cycle, the output voltage value also decrease. So if duty cycle is 0, then what is the answer of output voltage? That is also 0. So we can say that when duty cycle increases, average voltage also increases, and vice versa. So here let me draw one graph. So assume it is straight. Okay, so now it is not straight. Assume it is straight. So now here I am going to draw one waveform. So now here this average voltage is continuous or what? This average voltage is continuous or what? This is not continuous, isn't it? So whatever voltage generated, that is not on a continuous manner. the signal not going to be continuous. So here, sorry, this is not right. Yeah, so now here you assume it takes 1 second here, and so in the 1 second duration, so this is 50% is on period and this 50% is off period. So if I am going to connect this, so if I am going to connect LED to this, what will happen? It will not going to on continuous cycle. It starts toggling, because here you can see 50% on period and 50% off period. So here scale is 1 second. So that's why it is toggling. So what we need to do, so before that, let's find the value of frequency. Okay, find the value of frequency. So here we having formula to find the value of frequency, that is F is equals to 1 divided by time period. So F is nothing but frequency, T means time period. So here how much is the time period? 1 second. 1 divided by 1 is how much? 1 hertz. So if you connect the LED to this line, you will see the toggling. You will get fluctuating output. Now how to get the continuous output? So no need toggling we don't want toggling. So we need to increase the frequency of the pulse. So let me change the time to millisecond. So now we having frequency formula. Let's substitute 1 divided by 1 into 10 to the power minus 3. So 10 to the power minus 3. So 1 divided by 10 to the power minus 3 is how much? 10 to the power 3, right? So that is nothing but kilo. So we got the answer 1 kilohertz. Frequency is 1 kilohertz. So if 1 second you are going to generate pulse, then what will happen? That is toggling. But here we got frequencies 1 kilohertz. So now what will happen? This is the output you getting is continuous output. We are not able to see the toggling now. So when can apply? So when you apply any filter, then you can see a smooth analog wave. So this is about the PWM. So that is nothing but pulse width modulation. So initially when we connect the LED, we got the output is toggling, 50% on, 50% off. Then what we did? We changed the time to millisecond. So in that time we got the continuous output. So now we got the idea, right? How to do continuous, how to get the continuous output. Next is ways of generating pulse width modulation. Some of the microcontroller will support built-in peripherals to generate pulse width modulation. So using the built-in peripherals. If there is no built-in peripherals, then how to generate PWM? So at that time you can go with the timer. So that time we can generate pulse width modulation using timer. So if the control neither have built-in peripheral nor have timer, then how to generate the pulse width modulation? In that time you have externally generate the pulse width modulation. So in that case you can going to write a code with the help of super loop to generate pulse width modulation. So this approach is called bit banging. So what is bit banging? Now we got idea, right? You need to write a code with the help of super loop to generate pulse width modulation. So in the next session, let's discuss about how to generate PWM using the method bit banging. That's all about today's session. Thank you all.